Hi.
Hi, my name is Giuseppe Leccia, Product Marketing Manager for Teledyne LeCroy, and today we are going to show you the cable tester for HDMI. This is for physical layer. So basically it is a system that very quickly can allow you to define the quality from the physical layer point of view of the HDMI cable. Testing cable is not easy. Why? Because you have many different pairs, high speed and also low speed. We have the ERC, but also because the line rate is high. So how you can test very quickly the cable? This is, and the answer is the first dedicated test equipment. So basically, you see, you can measure the diagram, the insertion loss, the crosstalk, the impedance profile, then you see the insertion loss. Again, for all the high-speed lanes, you see the crosstalk. Crosstalk gives you the idea how much energy is crossing from one speed lane to the other. And the impedance profile. Impedance profile is fantastic because here you can see if you have any variation in the geometry along your cable, and you can test the quality of the connector for all the 4 differential pairs. And finally, we have the intra-pair skew. That means the difference between the positive and the negative for each line, which is really fundamental for HDMI. As I said, very quick, very easy, just plug the cable, get this measurement, and using a dedicated test equipment is a new class of testing.
So what are each of these cables?
Basically, here you have the HDMI cable. These are just 2 modules that are testing each of them at 2 different differential pairs. Here you have a digital oscilloscope up to 35 gigahertz bandwidth, and you can measure, as I said, the eye diagram, the insertion loss. Here you have also the TDR, time domain reflectometry, so the capability to test along the cable the characteristic impedance profile, which is fundamental in order to see, as I said, the geometry of the cable. If you have any mechanical variation, this is detected immediately, and this gives you the idea that there is an imperfection of the cable.
So it's connected to the board that you have there, and all the cables go out and in, back in?
Yeah, basically the only thing is just to plug the cable into the system, and that's it. What you see here is just the setup that has to be built from the beginning. Then you don't have to take care anything else. To do the calibration is very easy. This is the calibration kit, you see, that you are plugging along instead of the cable, and the calibration is done. So what I'm saying is that we are also making easier to get a complete calibrated system.
Do you need like a master or something to do the calibration, or how does
No,
that?
absolutely. There is no need of high-level expertise. Even if you're talking to impedance profile, you're talking to insertion loss, you can do this very easily for any kind of experience.
So this is the design that you have in there?
This is another adapter that you're using on the module in order to do some additional tests for the cable. These are done very quickly, and you can do what is called continuity. So really you can check every pin of the cable. Let me make an example here in order to see if you have any issue. So basically you see here the 2 ports of the HDMI cables, right? And for each pin, you are making sure that you have a connection from one side to the other, and you don't have any short or any kind of open. You know, this is really fundamental because, remind, cable is going to very expensive device. Any small issue that you may have on the continuity of the cable can lead to big trouble on expensive devices. So you need to make sure that everything is fine. Even more, we have the measurement of the resistance for each of the pin of the connector. Even in this case, it's very important. If you look at the value, are very small value in terms of resistance. Here we are talking about fraction of ohm, so the precision, the accuracy has to be in the range of 10 milliohm. So in order to do this measurement, you have to use a digital multimeter, so it's not easy at all to get this measurement done. As I said, the full set of information gives you the confidence to have a perfect cable and really to be able to use the cable for your own key kind of application.
So this is a new
It's a new class of instrument. It's a dedicated test equipment for HDMI and USB Type-C cable. Up to now, the only way to test cable was to use general purpose test equipment, vector network analyzer, oscilloscope, time domain reflectometer. Here we have instead a dedicated solution. So in somehow it's really give you the capability to do things much easier and quicker. Last point I would like to mention is active cable. Now this system is also able to deal with active cable, which is an additional kind of complexity that we can manage and we can make easier for customers to do testing of active cable.
So there's optical.
I mean, at this point we are working, when we are saying active cable, you are referring to a general class of instruments. We have linear redriver active cable, we have retimer active cable, we have optical active cable. So what I'm saying is that there are different classes of active cables.
And they're all supported.
And currently our idea is to get through all these classes of instrument of cable to be able to support all of them. So we start with linear active redriver cable.
The industry been asking you to do this for?
Currently this is a big challenge in the sense that currently in order to test this kind of cable you need to get a complex system based on time domain, so you need to get a bit error rate tester, you need to get an oscilloscope, again you need to get the multiplexer, the test feature. So
which are expensive?
Absolutely, but even more is very difficult to be used, and the throughput is very limited. So you can test 1, 2, 3, 4 cable. Here instead, with this system, you can have a throughput in testing cable which is much higher and really much easier. So as I said, it's a dedicated test equipment. This is one of the advantages.
So you can test every cable?
Yeah,
at the factory?
This is indeed focused for manufacturing, but also for quality assurance, as I said, because the level of measurement are quite signal integrity kind of measurements.
Is there any robots that can connect the cable automatically?
That's the next question.
Yeah.
In the sense that this is the only mechanical need, so someone that is still connecting the cable.
And looking at the numbers?
And just the report is automatically stored, so really you
everything is green,
yeah,
shipping.
Absolutely. Everything is stored automatically. You can retrieve the data at the later stage, so you don't have to do any action in order to get measurement done, because the idea is to get this done quickly and really.
Does your company work with the whole industry? Everybody is customer?
Yes, currently, as I said, we have different class of customers, we have different kind of need, we have production, but we have also a big request for quality assurance. Because as I said, cable are used for also critical application, medical application, aerospace and defense application, and in this case, you need to be sure that cable has very high quality. Now, it's very difficult to get this statement because you need to rely on the certification, but you cannot really make an assessment between different cables, and that's a big request.
Expensive, but this one gets pushed a lot by the person in the factory.
Yeah.
If something breaks here, you just replace to a new one and then everything is okay?
That's perfect. This is indeed another point. The way we have built the unit is to use adapters, inexpensive adapters. Just to give you an idea, here we are talking about $100. So the idea is to make sure that you can replace the adapter and not the module. So basically with for two reasons. One, to change the technology, because here we have HDMI, but can be also USB. The second one is because there is a number of insertion that, you know,
you can break the connector.
Yeah, so basically for USB it's 10,000 insertion, for HDMI can be similar. So after a while, testing million of cable, you need to consider to change the adapter. So this is also an architecture that has been thought from the beginning regarding this test tool.
And what do you show here?
Here we have instead, again, testing not only cable, but in this case also a device, a system which is generating and also analyzing an HDMI signal. So here you can really generate the signal in order to test the display, or you can really use this system in order to analyze the signal received by a generator. In this case, it's a protocol kind of solution. So here we are really making a protocol analysis and see that everything is fine. So here we have physical air testing, here we have protocol testing for, let's say, cable, but in this case, specifically for the protocol, also devices. So we are looking to monitors, we are looking to a set-top box of this kind of tool that are using HDMI signal.
Camera?
Cameras, of course, yes, there is
so many things, right?
Absolutely. And at the end, this does not make difference in the sense that you are selecting the right resolution, you're selecting the right everything, and that's it. It's protocol enabled. So really, you are selecting the protocol that has to be used by the device. And
is this more like for when the device is being engineered and prototypes are being made?
Yeah, this is absolutely.
It's not at the manufacturing.
Absolutely, this is covering a quite range of application. Can be engineering for R&D, but can be also, let's say, installation or making sure that everything is fine from the deployment point of view. So there is quite a list of variety of application that can be covered by the protocol analysis for cable.
Is there a whole network of ways that customers rent these a little bit, and then there's some kind of like agent that comes and tests a little bit and then goes to another customer with a machine? Or they have to buy it, they just keep it, all of those?
Currently we are always looking to the market request and trying to adapt and to do the best in the measurement community. So we don't have a scheme that has to be followed, rather than look into the market and adapt in order to be able to address the needs that are coming up with the technology. So this is the point.
Hi, my name is Neil Kendall. I'm Product Marketing Manager for Teledyne LeCroy for the video products. We've got two pieces of test equipment here. We have the M418, which is a functional tester, video generator, video analyzer for 8K HDMI. You can see it's putting an image up there, HDR, high dynamic range image. It supports a variety of functional test features, including monitoring the aux channel, the DDC channel. It's got audio patterns, a variety of test patterns. And this device down here, the M418H, is a test instrument, very sophisticated, that does deep capture analysis for sources, and a wide variety of very sophisticated functional tests and all the compliance tests for HDMI. In fact, if you need to get certified for HDMI for the logo program, you pretty much need this M418H or its associated product, the 980 48 gig module, in order to run all the compliance tests that are required for the logo program for 2.0, 2.1. And so that's the M418H.
And are there some design houses or some places where the different factories can go to get it tested when they launch a new design?
Sure, authorized test centers. There are several of them around the world. You can test and get certified through there, and they will use our equipment as well. Or you can self-certify in your own lab with our equipment under certain conditions.
And how do you do the signal analysis, what do you call it, deep packet?
Okay, so we have a unique solution in that we can look at all the packets going across the main link, whether they be guard bands, preambles, all the metadata, all the packetization in fixed rate link protocol, new with 2.1, the 8K standard. There's also metadata and video and data island information as well that we can all see. You can see if it's there, you can see if it's in the right place, and you can see if it's populated correctly.
And this kind of data that you need to analyze is throughout the whole video signal? Is the whole 48 gigabit? You have to look in the whole, or it's not just metadata or something like that?
No, we show all the data on the main link, including the video data, all the high-speed data.
All right. It's fascinating to understand how there's so much data going through the HDMI cable.
Yeah.
It's really interesting to understand what goes in those 48 gigabits per second. It's a lot of data.
It's a lot of data, and we can show it all. You can view it all in our protocol analyzer, the guard band, preamble, data island, the high-speed pixel data, the audio data that's embedded in the blanking, and so forth. There's also the eARC data that goes out in the opposite direction of an HDMI cable for audio to go out to a soundbar. We can show all that as well.
All right. And you have stuff on your website, people can learn more about this?
Right, so on the website, if you're interested in learning about HDMI protocols, if you go to our website, you can find a variety of webinars on the HDMI protocols that exist in 2.0 and in the new 2.1.